Good afternoon, ladies and gentlemen. If you've just come in from lunch and you missed our lunchtime power panel, you'll rue the day. You'll make tomorrow's one. Next session, Adaptivity, building the enterprise cloud. I love the thing that comes at the beginning of this, so I'm going to get out of here. But first I'm going to say good morning, good afternoon, good evening. Watch what's coming up next. Tony Bishop from Adaptivity.
Great, thank you. Sort of to kick off the mindset, probably a few of you have seen this, but I know there's a lot that hadn't, and an awful lot more people here this afternoon versus 7:30 this morning when I went through sort of some similar topics. So we're going to watch a video. Go ahead. Watch on the screens, and then we'll chat.
Imagine, for a second, if the design and construction of buildings had just been invented like 60 years ago. Seriously, no one had heard of foundations, beams, windows, anything to do with buildings at all. Okay, now a few geeky kids, for the first time ever, invent a simple little shack. Then other people start building them. But there's no standard types of materials or tools or terminology. Some buildings are really inefficient. Some are awkwardly designed. And while everyone wants increasingly bigger and more complicated buildings, there's no codes or regulations. Just a bunch of cowboy builders making things happen. Buildings weren't invented 60 years ago, but let's be honest for a second. This is really how information technology developed, right? 60 years ago, no one knew what a computer was. Yet computing advanced rapidly without any rules or regulations, or without common terminology or materials. All the while, IT systems became essential to doing business. Well, you can't build a great building without everyone following blueprints, or without guidelines to ensure everything is compliant. But our IT plan is just to find a team of get-her-done cowboys and have them build and patch as fast as they can. As a result, we create IT systems that, if you compared them to a building, they only use 25% of their floors, and they tip with the slightest breeze. When things go wrong, we ask the CIO and his gang to bring temporary order to the town. Okay, these three humps represent the stages of developing an IT system. And here's how much money goes into each stage. Although this hump demands our attention, strategically investing here allows for the operating expenses there to decrease. So let's talk about design. In construction, we've adopted standards and rules based on math, logic, and experience. And we've put all of this intelligence into a tool that lets us design blueprints quickly and reliably. As a result, we can build things that are frankly quite impressive. In the same way, there's math and logic and experience behind successful IT. But here's the thing. There's no tool that leverages that intelligence, so it's left to each IT guy to interpret and design however he knows best.
Ooh la la.
We thought that it was about time that this tool existed, so that your business can quickly and efficiently design blueprints for your IT systems. When there's a problem, you don't have to run and gun to fix it. You now have standards and rules within this intelligent tool. It'll help cost, quality, scalability, time to market, and help you innovate for new problems. To bring this all home, let's take an example near and dear to our hearts. Moving IT to the cloud. You see, the cloud makes some of our normal IT concerns even more disconcerting. Yet we know that moving IT to the cloud is inevitable. So, if designing IT systems for the cloud was compared to, say, designing buildings that could live in the sky, well, you could spend a lot of energy in post-deployment running and gunning trying to get them up there. Or you could start to seriously consider spending a little bit more time on design. We vote design. It's time to take IT to the next level. Prepare for blast-off.
Great, thank you. So what'd you guys think? Pretty cool? Good way to start the afternoon. Thank you. So why should you listen? Why us? Why the folks at Adaptivity? I think that so background-wise for you to know is we're a bunch of guys that came out of Wall Street technology. Before that, we were in telco and a couple other environments. We built probably what's one of the largest private clouds still out there running today. It's 50,000 nodes, 16 data centers, 300 applications running globally in a managed on-demand kind of cloud utility paradigm. We also have lost our hair, wear glasses now, got a little heavy around the waist, those kinds of things that come from the stress of it. So we've been there for most of you that are on the side of being the users and trying to figure this mess out. And one of the things that we realized a couple of years ago, about 2.5 years ago, we started the business was, boy, if we could codify what we learned and then be able to continue to plug in expert knowledge around the different components and the multiple dimensions of how you build and design enterprise IT systems to exploit paradigms like cloud computing, like virtualization, dynamic data centers, so on and so forth, wouldn't that be great? So really what we have is we actually have a tool called Blueprint for IT, and that's the concept that we're going to talk about today is in building an enterprise blueprint, there's 4 fundamental things that we've learned. And that's what I want to make sure I hit on today that you walk away with is that there's 4 takeaways. We've written a book about it. You can find it on Amazon if you want. You can Google and see the things that we've done. You don't need to work with us. You don't need to buy our stuff, right? But what I want you to hear is that the way you approach enterprise IT and utilizing all this great technology and strategy, it's these 4 things. 1, the root cause of the way that IT provides delivery limitations in meeting the needs of the business or has achieved that in terms of not meeting those needs and expectations is directly linked to how systems are built, deployed, and run. All right, so let's not lose that concept. The way IT delivery limitations are directly linked to the way they're built, designed, built, and run. So that's architecture, engineering, and operations. All right, and we're going to talk about that as we go through. Secondly, enterprise clouds. I don't know, out of the massive group in here now, the few that were in here this morning, how many were in here this morning when I talked this morning? So we talked this morning about cloud, the intersection of business processes and how systems are engineered. So to think of cloud and to be able to have the dialogue with your business to take advantage of why we need to do this and how we can change the delivery paradigm is that you've got to understand that it's how the business process intersects with the way systems have been engineered and the way systems need to be engineered to be able to take advantage of a cloud model within the enterprise. Third, probably a very important point, IT has become the new supply chain of the business. If you do not start to think of IT as the supply chain of the business, then you're fundamentally missing the strategic opportunity that is now converged in here today that you can take advantage of. The maturity of the technology, the maturity of the processes, the economic model challenges that are out there, and the proof points that are out there. There's a lot of exciting proof points. And finally, enterprise clouds. And notice I didn't say public cloud, private cloud, hybrid cloud, which there are all those classes. Enterprise clouds, right, are the new business delivery paradigm. So when you're thinking of the design and you're thinking, how am I going to change and how am I going to take advantage of all these different technology components, it still has to come back to that delivery paradigm, and it has to come back to how the business process intersects with how systems are engineered. So I think I've nailed those points, but they are the 4 points that I want you guys having in the back of your head as we walk through this. So what are the barriers to being able to build to a cloud? The barriers start with understanding how systems have been built and how they're delivered today. If you follow top to bottom, you can see every line of business creates their own applications. They procure their own servers and storage and network-associated bandwidth. They procure their own databases. They build and deploy them within these silos. Notice the complexity of the arrows between the various application services and how they interact with the infrastructure. How many in here have ever utilized tools to actually create dependency maps to see how your existing systems talk across? Hands up. How many that you've seen those maps? So for those that haven't, which seems to be a big majority, it looks like a bowl of spaghetti. All right, it is like it's like a spaghetti. What do we used to call it? Spaghetti transaction flow. Right, just weaves its way through the data center and across your various parts of your organization, and it's problematic because this is where that delivery limitation occurs. It occurs because of the way these things have been built. So the requirements are being lost because the application guys say, well, I've got the requirements. You don't need to know system guys on the IT side. So you just go ahead, you know what, I need these servers. Or the systems guys go, well, these are my standard servers. These are my standard storage. This is my standard networks. I mean, how many of you have ever been on a production call in these enterprises where you actually say everybody gets on and the application has a problem, but everybody says all their lights are green? Anybody have that in here at all? Right? So I don't know if you haven't, it's the most frustrating thing in the world, because what happened is the linkage between the application and the way the whole thing's delivering and executing is part of the problem. So business requirements are manifested through workload demand that comes from applications that execute across systems in the data center. That's the point of the message, and the way that they've been built and deployed in silos. If you've ever gone into a data center, because even if you go to the cloud, you still got to connect your existing data center to the new data center that's in the cloud. So in understanding the data center, if you're ever to go through it, you would see that they have an area of football fields where you have security zones. You have servers of certain types here, servers of certain types there, SAN devices over here, NAS devices over there. And then depending on the type of application you run, well, there's some middleware boxes, I think somewhere's over here. And then if you ever trace that through a network, you have these hops going up and down, where you actually say, how am I supposed to guarantee the execution path when what we've built and deployed it on can't even guarantee the execution path? So understanding, when you're going to go build an enterprise cloud, you fundamentally have to understand what you have today and where you're going to go tomorrow. And we're going to walk you through how to do that blueprint. Okay, so 4 core components to an enterprise blueprint that you are building. You wouldn't build a building without a blueprint. You can't get a certificate of occupancy without a blueprint. You can't do a renovation without a blueprint, right? You can't get your permits without a blueprint. So we need to start doing that in IT. And it needs to fundamentally take the same dimensions. You build a blueprint, for a building. You've got architectural. You have the engineering, right? You have structural part of the engineering. You have electricity. You have HVAC. You have plumbing. Well, the same thing has to be in IT, and those 3 core dimensions that you have to put into your design is the architectural side, the engineering side, and the operational side. And if you do not link all 3, you cannot build a blueprint to translate and take advantage of the cloud. The cloud is a delivery paradigm. Secondly, correlation. If you do not understand the application workload, and you do not understand how that application workload consumes your supply today, how can you take advantage of a new supply model tomorrow? You can't. I mean, you could try, but you don't effectively change the delivery paradigm, and you don't institute the controls. The third thing that you have to do in your blueprint is you've got to rationalize your infrastructure. All right? And rationalization just says these are my vendors and these are my standards. You need to rationalize your application portfolios, your standards of how applications are built and deployed, so you can take advantage of all these new great technologies that allow you to package and deploy these applications quickly. You need to change your runtime software. How many people in here think that in their organization they have hundreds to thousands of combinations of platform software that run in their organization or data centers, right? If you don't think that, guess what? There are. When we were at Wachovia, we had to go from 400 different combinations down to 12 in a year to make our cloud work. Because if you don't simplify that engineering and really understand what is that workload, what is that application supposed to do, and how am I supposed to run it, and what does it really need, then you can't take advantage of flexible, elastic, on-demand type models. And finally, systems management. It's like been the poor cobbler's son afterthought of IT. You've got some really slick system management tools here today that are out there in the crowd, and you really need to take a look at them, because systems management, in terms of how you look at the instrumentation, the logging, the monitoring, right, and how things are provisioned and reprovisioned and purpose, and the ability to run IT like a business, right, is something you're going to have to focus on. And if you're not focusing on it and you don't have a good discipline in your organization, then you're going to have trouble with moving to the cloud. Finally, your operational model. Your operation model cannot be recovery time objectives. Your operation model cannot be just availability. Your operation model has to be about quantification and qualification of time, frequency, business calendar, exception events, right? Conditions. What are the conditions that they can accept different ways for different things? along with disaster recovery and business continuity. So let's set a taxonomy. The taxonomy is there is a business platform. The business platform is a collection of applications, information, and content, right, that support the way the business originates and fulfills and supports their customers. That business platform consumes IT supply. Where the cloud comes into play is it's going to intersect between the demand and the supply to become the new delivery paradigm. And to do that, we're going to have to change how we architect, organize, right, manage, and deliver IT. And the resource model, you have to start thinking of the resource model as a series of service units that mix and match different attributes of computing, network, storage, and operating environments that allow me to deliver different types of processing in support of the different functions I need, whether that's an external cloud provider or it's an internal cloud model or a combination of both. Multi-dimensional design program. Now, I bet you guys can all read that, what's in the middle of those boxes, right? In the middle layer. Isn't that great? Marketing guy told me once that, the best thing to do is throw up something that's graphical and color and has a lot of information in it, and then you can talk about whatever you want. So, right, Brian? So, top to bottom, business platform, cloud delivery, data center infrastructure. What I want to call out to you is two things. The way you assemble infrastructure components, number one, and then you plug in the way the delivery model of internal, externally provide it, number two. And then number three, you see on the green lines it says ERP for IT and security. Anybody in here ever heard of the concept ERP for IT? Anybody ever heard of ERP? Can I get like a hell yeah? So, ERP, we can borrow from this, right? It's enterprise resource planning. It's looking at the assets of the business and how they're managed and the transactions and so on and so forth of the operations. While the same discipline has to occur, what cloud's going to allow you to do is change fundamentally the economic model and the delivery paradigm. So you better have a management strategy to how you manage the resources and the services of IT that has a discipline to it that allows you to say, ooh, I can optimize this way or I can optimize that way. And oh, by the way, security has to be across all of that too in the design. And security is not a limitation. Security just means you've got to do it different. Right? There are technologies and capabilities out there today. You just got to do it different, which means you better figure it out in the design, top to bottom, when you're figuring out how you're going to deliver what you need to the business at the same time. So, multidimensional design program. How do you get there? It's a simple, continuous process. Number one, understand business behaviors as workloads. All right? It states here, characterize the business activities and functions in a digital context. The simple thing is there are applications, there are business functions. Business functions and activities use applications to do what they need to do. You need to understand the workloads on a supply chain basis as they go across. And if you can only start one area or start where there's a problem area, then that's what you do. Start where there's massive consumption issues or massive delivery performance issues. But you want to be able to understand the workloads. You want to translate those workloads of what are those workloads consuming in terms of IT resources. Middleware, application servers, web servers, messaging environments, operating systems, data sources, content. Oh, along with compute network storage and bandwidth. Because you got to tie them all together. Because if you want to change it, you got to be able to link it to that. So once you understand the behavior of the workloads, and then you understand what they consume, then you can start to actually decompose the fulfillment model. Notice how many people in here typically say, when I go to fix something, I'm going to actually look at the current existing IT system and then tell them how we can fix it versus looking at the workloads. It's a typical approach. You've got to link the workloads to what it consumes, then to how are those systems built and deployed, and then to what's missing or what could be changed to allow me to change that delivery paradigm. And that delivery paradigm is virtualization technology, is lifecycle management technology, is management technology, is workload runtime management, is packaging and deploying, is orchestration, is repurposing, reprovisioning. It's all those things that you hear that are out there with all the vendors that are here that have built some really world-class stuff. But they're all a set of capabilities. You've got to figure out, well, how do I plug those in based on where my gaps are, and then what are going to be my delivery models that I'm going to exploit? But the only way I can do that is if I can set the policies and understand what workloads I'm trying to address And based on those workloads, what resource delivery paradigm do I need to provide to support that, or could provide alternatively? So, shaping the demand in the fulfillment model. Look at some of these, and it's probably a little harder, the qualities, but do you know, workload-wise, for every one of your applications, have you broken down things like asynchronous message delivery, number of protocols, synchronous message delivery, data source integration, workflow quality of service, workflow unit processing, workflow concurrent units, workflow degree of concurrency, volatility of rules, reusability, event-driven, service orientation of the UI, degree of exception-based processing, all kinds of explicit availability requirements. We have 82 that we figured out that you got to do. If you don't know this, then you can't build the cloud. But it's not that the cloud can't be built, because this is, to me, I call anybody out that says you can't build a cloud and you can't make it production enterprise class today, I tell them they're full of crap. Because we've done it, and we've done it for the most extreme use cases in the world called Wall Street. Now, maybe Wall Street doesn't know how to figure out credit risk, but they do know how to build IT systems. They're also dealing with the most crazy sets of volumes and fluctuations and unit works. You know, they measure microseconds these days, guys. You know, and then it's microseconds to seconds to minutes. How do I get it all done? So the only good part of there is you actually learn how to do, you know, if you can come out of there and survive that world without, you know, having an ego and a misunderstanding of Main Street, then it's probably a good place to learn. But it's this kind of granularity you need. But if you get this granularity, there's nothing stopping you that you can't do cloud today. So how do I correlate the demand profiling with the runtime engineering? Demand, supply, fulfillment. Get that in your brain. What's the demand? What's the supply? And what's my fulfillment model? Right? Well, then I better understand where demand occurs. Demand occurs from users and applications generating files and messages. All right? Either requests for them or inputs of them, or a mix of both of those. They come through in terms of transactions and events and data feeds and schedulers that then are coordinated through data handlers, enterprise service bus, session queues, right, that then invoke services, rules engines, protocol translators, security modules, business logic. This is what creates demand on the supply. And if you're an IT person on the system side and you don't have that profile understood and that process map flow of how that executes, of where that demand's occurring to those models, you can't build an optimized delivery system with it. So this is how you start to move to it, and then you can start to determine that if you understand that, it makes it real easy to say, hey, you know, leveraging something like RightScale tied to Amazon or tying in, you know, Abaquo to do stuff internally, or any of the guys that are here, it makes it a lot easier to then exploit these kind of technology capabilities. Next thing you need to do, you need to understand the topology flow of the execution paths of those workloads in your data center. Because if you're going to take advantage of external or alternative ways, you have to understand it. And as you can see the spaghetti flow, this is a typical model for a single application across multiple parts of a data center. Why would you have it spread out like that when different applications are talking to each other? Why wouldn't you group those together with the way you deploy it? From a network topology, not a physical, but a network topology standpoint. Right? Physics come into play. The ability to move things closer together or understand that, and then understand how to put the fulfillment model in, is what's going to allow you to realize that enterprise data center. Rationalize the application infrastructure footprints. You've got to go through, why do I need all these different combinations of builds? Right? If I'm only supporting certain types of workloads, why can't I have those workloads standardized on a certain set of builds? It makes it a lot easier for you to then take advantage of automation technology to package and deploy and quickly spin up and spin down. But you've got to be able to do that. So that means you've got to go through an exercise of rationalizing it. Again, remember, I'm talking about enterprise class IT. I'm not talking about just spinning something simple up onto an Amazon. And no offense to Amazon, I love them. But the key is, on an enterprise IT basis, you've got security and availability and regulations and so on. And you have this expectation, so you've got to clean out the garbage to be able to take advantage of the new. You've also got to start to look at your network fabric. If you do not start to unify the network fabric between the compute, storage, security, all together, I don't care. Use Cisco, go with HP in their pieces, or Juniper. They're all going to bring you together. But you've got to collapse it. Because right now what's happening is you're going through hops in your data center between servers and over and translated into storage and back again, and then hopping over between different environments in the network. All of these have to come together, and you've got to unify your network, and then you've got to make it so that you can shift, if it's virtual appliances and fabrics, that they can be moving back and forth across these hops in a stateless manner that allows you to have that elasticity, ability. You've got to also start thinking about virtual users in the enterprise. Enterprise mobile computing, iPads, right? Everybody's seen the iPads. Everybody's heard about the iPads, right? It's just the start, guys and ladies. Get ready. It's coming. It's coming tremendously fast. It's going to explode. You have to have, it's going to be smartphones, and everything else is going to be virtual clients, right? Or smart tablets. Everything's going to move there, and especially in the enterprise, because the business is going to want to do business that way with their clients. So you as the IT folks are going to have to do this with them. So you're going to need to start looking at that, and you're going to need to start saying the biggest thing I got to do is I got to get rid of the complexity of dealing with hundreds to thousands of desktops, right, that I got to do patches and updates to and everything else to. Move it into the data center. You've got alternative strategies there. Get it so you're running it out of your data center model, because virtual clients is critical to you, and a virtual application delivery is critical to allow you to start to change the delivery paradigm into different cloud models where they don't care where it is as long as they can get to it securely. Holistic virtualization. Probably if you read any of my blogs or you've seen anything or other talks, I will state to you that, God love VMware and Zen and all the others that are out there, but that is not the be-all, end-all of virtualization. All right? And you've got to get that in your head. The answer just is, well, I slap a VM on and I'm done. If you're not virtualizing your applications at the app tier, if you're not virtualizing the workload to be able to make the workload portable, and if you're not, and be able to mix and match across different, and if you're not virtualizing the data tier, and if you're not spending time driving Oracle crazy with, tell me how I can virtualize my data, then you're not going to be able to build the most effective cloud delivery paradigm. Because it's simple, guys. If I have to read and write data against a hardwired environment versus an abstracted environment, how do you think it's going to perform in an abstracted environment versus a hardwired environment? I'm going to have physical limitations in the hardwire is the answer. So you need to be able to tie those together. Execution management. There are technologies today that you can implement that can do smart analysis, real time, of what's happening, of arrival rates of messages into your session queues and your message queues and so on, and can look at queue depths and say, ooh, we need to flex to adjust to accommodate this. It works faster than a human. It's something you have to do. There are many technologies out there today that can do that, and you need to incorporate that. And you need to incorporate that into creating a hot type set of environments, right, where you can persist at the workload tier and be able to take advantage of alternative delivery paradigms. I don't know about you guys, but it's awfully freaking hot in here. Next thing, we talked about it earlier, operating model. You've got to create a service utility operating model. How many people in here buy things on a capital allocation basis and then bill it back with some sort of chargeback model and some sort of uplift to handle the people with it, right? So, bad way to do it, but that's the way the model is. So one of the things is until you can change the business and the finance folks, you've got to be able to implement the capabilities that shows them who uses what, when, how, show them what they're asking for and what it's costing us to do, and then be able to turn around and say to them, and here's what I could do for you alternatively. They use this thing called business intelligence, right, to make decisions about clients' transactions. Maybe we should do a thing called IT intelligence and actually start to learn about what's happening in the infrastructure and then show the business this is what's actually happening in the infrastructure. So you've got to enforce that model and start to set that in place. And one of the keys that we did when we were at Wachovia was we actually created SLAs, ELAs, and OLAs. Usually you hear SLAs and OLAs, right? But the ELA is what is that execution, right, supposed to be, and what is that execution can be in exceptions events. And we got down to that kind of discipline and made it a lot easier to start to charge premiums for that ELA exception events. And it also made it so that we could start to have a dialogue that says, well, it's your behavior, the way you consume stuff that's causing it. It's not the way I run IT. It puts you in a much more powerful position. Finally, I can't stress it enough. If you do not get your runtime monitoring and management linked back to the way you dev and build and test also into a discipline with the data and trending and analysis put to it, you cannot change it. You're going to have just the same mess now running in a different way that could break differently. So you have to get that environment in place. And finally, the service delivery model. You can't have a build and release process that takes a week to approve things that you can do in seconds in the runtime. So you better figure out how you're going to do that. Runbook automation. You better build processes. Wouldn't it be nice to standardize that says, look, if I can pick and select in a self-service basis in these standard builds and these standard requests, I can get my stuff put into production in minutes to hours, that you've got to have a process that can accommodate it. And yes, it needs to be ITIL compliant, right? But it needs to be ITIL compliant, built to your operating model, how you run your utility. And finally, end-to-end governance of the design. You have to institutionalize this because the way to exploit and proliferate cloud through your enterprise has to go through an end-to-end of governance of design where you're constantly linking new designs, new concepts, and new technologies that you're trying to take advantage of in your runtime back into the environment. So it has to be a holistic process. This is the only way we found, and as we work with big firms today, that you can institutionalize this on a consistent basis instead of it being a pilot project that goes nowhere. And with that, I stayed on time. Thank you very much.
Thank you very much. There is time for a question before you go to the session, if they have one. See, they want to go to sessions, Tony. They don't want to be kept.
Can you put up the business card again?
Ah, there's a question. We can help with that. Can you push the business card slide?
It was that intense, everybody's afraid to ask a question, huh?
Yep.
Well, we're definitely at the booth, our Adaptivity booth, if anybody wants to come by and ask questions privately one-on-one for any more. And we certainly appreciate the time. Thank you very much.
Thank you again, Tony.